Let's set up a pressure vessel design study using SolidWorks Simulation. Just like any other simulation, we start by going to a new study and selecting the study type. But unlike any other study, there's almost nothing to a pressure vessel setup because it's a hyper-focused tool specializing in ASME boiler and pressure vessel code. They're just two simple steps: combine existing studies and review the code-compliant results. To combine existing studies, you right-click on the Sole option, Setup. To define the setup, you select how you want to combine the studies, linear combination or square root sum of squares, and then select the study from the dropdown and set the multiplication factor. 1 would be the exact same, and a large number would multiply, and a smaller number would reduce the loading. That's it. The study is ready to run, and move on to step 2, the results. Isolating just the pressure vessel shell, we can easily take a look at the results. By default, we're looking at the von Mises summary stress, but that can be easily changed. And here is where the magic happens. First, setting the results to show the stress intensity for the maximum normal stress range, and then to show the membrane stress. There it is, just a few clicks to get the results so you can make code-compliant decisions for your pressure vessel design. To take it a step further, you can investigate the results of the flanges. Unlike the pressure vessel shell, these were meshed using solid elements. That's not a problem for simulation because of the stress linearization function. With a section clipping turned on, you can see through the thickness so you can really hone in on areas of interest. Right-click on the plot and select Linearize. Then calculate this between the points, and the summary of the membrane and bending components gives you everything you need to know to make more code-compliant decisions with your pressure vessel design. You can visualize these results in a graph, or even export them out to Excel to document the design. That's it for a pressure vessel design study, a hyper-focused tool specializing in pressure vessel design. Obviously in this video, it was easy and straightforward, but that's because it was built on a foundation of 3 existing studies. In this example, we had one for the pressure, one for the loads on the nozzles, and one for its own weight. Let's take a look at the setup for just the internal pressure by creating a new study piece by piece. First is the material and geometry setup. It's steel, and the thin pieces were shells, and the thicker flanges were solid elements. I can drag the setup pieces from one study to copy to another. Next is the connections, or how the geometry interacts with each other. In this study, we used virtual bolt connections to accurately account for their effect without adding to the simulation time. These are great time savers that don't cost anything in terms of accuracy. Third was the fixtures to define how it's held in place. Then the internal pressure of 165 psi. Now we're ready to automatically mesh and run the study. Now, that was just one of the setup pieces that went into the pressure vessel simulation. Obviously, pressure vessel simulation in SolidWorks is incredibly easy because of its hyper-focused, specialized nature. After the initial groundwork of setting up a regular static study, all that's left is to get proper results to help you make code-compliant decisions.